And again, I'm sorry, this isn't ideal, but we're going to do one more problem on 5.5, and then we're going to get into 5.6. So those of you on Zoom, I should be able to hear you. So if you have a problem, just let me know. I also know that there's some glare, but we're just going to be okay with that. Actually, let me see if I can just get rid of one row of lights. I think it's the middle row. Yeah, that looks better on here. That's as good as we're going to get. So over one of the days we were doing online, I couldn't get my thing to connect to the computer, so I just AirPlayed at my house, but it won't let me AirPlay this onto my computer and then AirPlay the computer to the big screen. So I'm just, this is what we got. So. All right, anything from me before we get started? I get my final shot on Thursday, and so I'm just playing it real safe until I'm fully vaccinated. Yeah. Oh, yep, and of course I told you that, now I didn't look for it. Yep, let me look. We're gonna look at this problem right here in the middle. Once I get Aiden's note sheet. And I have my calculator up because we're doing a ton of calculator stuff. You can choose to just listen to what I'm doing, or you can follow along. These are all we just have one day, so you can do it on your iPad for today. Okay. All right. So again, we did all the way up to 5.5 except for this number 4. So that's where we're going to go now. I also assume you didn't do a lot of pre-cal over our long weekend. So I'm just going to kind of talk like you've never seen this before. Hopefully we catch on. But if you need me to explain something further, just let me know, okay? I'm going to take it like you haven't seen this for a long time or ever. So 5.5 was law of sines. Remember, law of sines was like sine of an angle over its opposite side equals sine of another angle over its opposite side. You either need 2 angles and 1 side, or you need 1 angle and 2 sides. That's going to be different in a second because I'm going to teach you about law of cosines later today. But all we know right now is law of sine, so we have to use one of these 2. I've got this picture drawn, and so we're going to redo a couple things on here so I can actually use it. I gave you 38. That's the distance between north and east, though, that in this problem, a meteorologist sees a tornado from their lookout point. So in order to put it on the triangle, I need to remember that this is a 90-degree angle. So if I do 90 minus 38, I can find that the inside angle is 52. So I'm going to label that. And I'm going to do the same thing on the other side. Again, they didn't give me the angle inside the triangle, but I know we've got a 90-degree angle here, so 90 minus 53 is 37. Now I'm focusing on this big, acute triangle I've got here. I've got 2 sides, 2 angles, 52 and 37. I've got 1 side, which is 25. I want to find the missing side, or the missing angle, before I do any sides. We know easily that all the angles in a triangle add up to 180, so I'm going to do 180 minus 37 minus 52, and I get, that's not what I wanted. And I get 91. Ooh, so close to a right angle, but not quite, so we don't get to use normal trig. We have to use sine, cosine, tangent, all that fun stuff. I'm going to argue that we need to find little a and little b before we go find little h. And I always want to use the pieces that were mostly given to me. So I'm going to do sine of 91 over 25. And then we're going to do one for each of them. We're going to do sine of 37 over little b, and then sine of 52 over little a. So two of our equations are going to look super similar. I'm going to start though with sine of 91 over 25 equals sine of 52 over little a. Sine of 91 over 25 equals sine of 52 over little a. Cross multiply, and we start solving. So I get little a times sine of 91 equals 25 sine of 52. And then we want to get rid of my sine of 91, divide by sine 91 on both sides. Little a equals, and you can recopy this down. I like to write what I'm going to type in my calculator. So if you mess up typing in your calculator, I can see that you knew what you were supposed to do. In order to protect yourself, I'd show as much work as possible. But at any point, you can plug into the calculator. I'm going to do 25 sine of 52 divided by sine of 91. And I get 19.7. That's what I got last week. Any questions so far? Same thing for little b. So now I'm going to do the same thing, sine of 91 over 25, but then I'm going to say that that equals sine of 37 over little b. So sine of 91 over 25 equals sine of 37 over little b. It looks almost identical to the problem I just did, except instead of doing sine of 52 over little a, I did sine of 37 over little b. Does not matter, still cross multiply, still solve. B sine of 91 equals 25 sine of 37. Divide by sine 91. B equals 25 sine 37 divided by sine 91. 15.0. All right, 15 is good. Okay, so for both of these, we found the distance from the meteorologist to the tornado, from like tower A and tower B. I'm gonna go to my picture and I'm gonna write, for little b, I had 15. For little a, we had 19.7. Now, I want us to choose one of the little right triangles. So now I want to find the distance h. So you can either use the triangle on the right and solve that way, or I can use the triangle on the left. And I'm gonna solve. I just taught my geometry kids trig today, so I'd be like, all right, what's my opposite, what's my hypotenuse, etc. We've done that before, so I don't need to worry about that. I've got 52, I've got opposite, which is h, and I've got hypotenuse, which is 15. So I'm gonna do sine of 52 equals h over 15. Multiply by 15. 15 sine of 52 equals h. 15 sine 52 in the calculator equals 11.8. All right. So that was all the work we had to do in order to find little h. Anybody have any questions? I could argue this isn't hard, it's just a little tedious, it takes a lot of steps, you have to be really careful with whether you're multiplying or dividing things and plugging correctly, but I don't think technically it's pretty hard. So now we're officially finished 5.5. Anyone have any questions on this? All right, good job. We're gonna move into 5.6. 5.5, I'm gonna say it's due on Thursday. I want it due before we take the test because I want you to get questions, and that way we can spend all of Thursday just studying. So I'd like this done by Thursday. Okay, and I'll put a little Dropbox up on Schoology today. Again, I have papers to pass out. I'm gonna pass them out during lunch. I haven't graded your 4 homeworks or your most recent quiz, but I'll get those done tonight so we can talk about that on the day of the review too. So we're gonna move into 5.6. And I just spent all of 5.5 talking about law of sines. 5.6 is now called law of cosines. I think law of sines is easier than law of cosines. I don't think law of cosines is impossible. I just think there's a lot more room for error. I'm going to give you 3 equations. They're all the same, except they're just solved for different parts. So I'm going to write it and then I'll talk about it. A squared equals b squared plus c squared minus 2bc times cosine of a. I did not come prepared to prove this just for time. I know I proved it in the past. If you want to know where this came from, I can look that up. But at the end of the day, all that really matters is that now we're using cosine and law of cosine. Another thing to remember is that the side, little letters mean sides and big letters mean angles. The little side goes with the angle that we're doing cosine of. So the side by itself goes with the angle we're doing cosine of. And then the other two sides just stay on the left side of the equation or the right side of the equation, being squared and then being multiplied by each other. I'm going to do this now with b and with c as well. So same thing, I'm going to do b squared equals a squared plus c squared minus 2ac times cosine of b. Again, the a and the c are being squared and then multiplied, while the b, since it's by itself, is also the angle that we're doing cosine of. And then last, we'll do it for c. C squared equals a squared plus b squared minus 2ab cosine of c. All right, again, these are all the same. It's just nice to sometimes see them written out differently. Again, anytime you do this, the angle that you have and its opposite side are kind of like your bookends. The side is the front, the starting point, the angle is the back end, the final thing that you write. We're going to do 2 examples of this, solving the triangle out. I'm going to argue in both cases, you only need to do law of cosine once. On the other problems, we did law of sine twice before we moved on. I'm going to argue you can only do law of, or you should only do law of cosine once, A, because it takes a longer time, B, there's more room for error. And then the second thing you can do is a law of sines to finish the problem. All right, can I start an example? Okay. So the first one, I've got this triangle CHS. You can relabel it ABC, whatever makes you happy. Some of my other classes are like, well, how do you know what A, B, and C? Whatever you want, just make sure it's consistent. And I have given you 2 sides and 1 angle. Anytime I give you a side angle side like this, where the angle is in between the 2 sides, we must do law of cosines. So anytime I give you an angle side or side angle side like this, we must do law of cosines. Think about it this way, there's no other way to solve, right? I can't find another angle because I don't have a second one to minus from 180, and I don't have, like, I can't find that third side because I can't do Pythagorean theorem. So the only way to find this little side C is to do law of cosines. So I'm going to set it equal, little c is the side, it goes by itself, so I'm going to do little c squared equals, and you can call 10a or b and 12a or b, it doesn't matter, whatever one you want them to be. So c squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 58. Again, the things that are across from each other are the ones that go on the outsides. Any questions on plugging in? We're just going to simplify now. If I give you an angle and we're looking for the opposite side, this is the easiest way to simplify it. We can mostly put this pretty much straight in the calculator. I know that 10 squared is 100. I know 12 squared is 144. And I'm going to do this all at once. This is all being multiplied together, so I'm going to do it all together. 2 times 10 times 12 times cosine of 58. And I get 127.18. Okay, now I just have plus or minus, but they're all on the same side of the equation. So I'm going to do 100 plus 144 minus 127.18 to combine all of those things on the right-hand side. Minus 127.18. And I get 116.82. And then we square root both sides. Get c by itself. My biggest suggestion, if you're not following along with me on your calculator, is to go back and see if you can get the same answer as me. So like when you study tonight, tomorrow, Thursday night for this test, see if you can get these same answers. Because you might think, oh yeah, I can do this law of cosine, I can plug in, I'm all cool. But then if you get to the test and you're like, I don't know if this is the right thing, it's going to be really frustrating. So see if you can reciprocate this and make sure that you're getting the same answers on it. Okay, I found little c, 10.8. But now I need to find angle S and angle H. I think that I'm going to do law of sines to find either S or H, and then I'll just minus the angles from 180 to find the other missing one. You can do another law of cosines, but I think it's A, longer, harder, and it has more room for error, so I'm going to do a law of sines. Does anyone have a preference on whether I do big S or big H? Anyone care? All right, I'll do H then. I'm going to keep sine of 58 over 10.8, and then I'm going to do sine of H over 10. Sine of 58 over 10.8 equals sine of H, as in house, over 10. We're just going to cross multiply and solve. I get 10.8 sine of H equals 10 sine 58. I can divide by 10.8. Sine of H equals 10 sine 58 divided by 10.8. Is 0.785. And then once I get here and I'm trying to find out what angle H is, remember that I'm going to do second sine or inverse sine. H equals inverse sine of the decimal. And so I'm going to H equals 51.7 degrees. Anybody any questions? So I'm going to go label H as 51.7. And then again, I know that all the angles add up to 180, so I'm going to do 180 minus 58. minus 51.7, and I get 70.3. I'm going to do letter B before we go to lunch. We're going to do one more before we go to lunch. Any questions on this one? Okay, so this one I found a missing side. Hence on the next one, we're going to find a missing angle instead. So we're going to go kind of a different direction. Questions, thoughts, comments? Okay. Little c, little h, little s, that means I was given all sides. C, H, S. Little c is 3.2. Little h is 7.6. And little s is 6.4. Okay. We have to solve this entire triangle. I do not care which angle you find first. Just like the last one was a side angle side with the included angle, this one is all three sides. As I reminded you, law of sine needs one angle or two angles. You have 0 angles. So anytime you have side, 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 you also have to use law of cosine in order to solve this. So law of cosine, you either need 2 sides and its included angle, or you need all 3 sides in order to solve. Again, it does not matter which angle you find. I'm actually going to find h because that's the biggest one. I'm going to find h. So I recognize h and then 7.6 are opposite each other. So those are kind of my bookends of this problem. I'm going to start with 7.6. I'm going to end with h. I'm going to do 7.6 squared equals 3.2 squared plus 6.4 squared minus 2 times 3.2 times 6.4 times cosine of h. Oh, that's a big mouthful. Here's the equation I've written so far. Again, I'm finding h. Any questions yet? Okay, I'm going to start by doing my squares. I'm going to do my 7.6 squared, 3.2 squared, 6.4 squared, and then my 2 times 3.2 times 6.4. I'm not going to combine anything else. I'm just going to start by simplifying those. 7.6 squared is 57.76. 3.2 squared is 10.24. 6.4 squared is 40.96. 2 times 3.2 times 6.4 is 40.96. Cosine of h. Okay. I need everyone to listen to me because this is a big mistake we all make. If you listen to nothing else I've just said so far, I need you to listen to this. A big mistake we make is that you want to do 10.24 plus 40.96 minus 40.96. All of us want to combine those up and then take that and move it to the other side. You can't do that. This last 40.96 is attached to my cosine h. Those are being multiplied together, so it is not a like term. You cannot combine it with the other two. So you need to leave it by itself. I'm going to combine these two minus that from both sides and then see where I'm at. Does that make sense? Okay, tell if we're not listening or just no questions. So 10.24 plus 40.96 is 51.2 minus 40.96 cos h. Again, you cannot combine 51.2 and 40.96. I'm going to minus my 51.2 from both sides. And then I'm going to divide by negative 40.96 from both sides. negative 0.16 equals cosine of h. Remember, once I get here, I need to do inverse cosine of both sides. So second cos, or cos to the negative 1 of negative 0.16. And that's going to give me 99.2. $99.2 is little h. Okay. Now, again, you can do log cosines again to find one of the other missing angles. I'm going to do log sines because it's quicker, and then I'm going to minus from 180, and then we'll be done with this problem. Anybody questions so far? Okay, again, you can find C or S, it doesn't matter. I think I'm going to find big C. I'm going to do sine of 99.2 over 7.6 equals sine of C over 3.2. 99.2 over 7.6 equals sine of C over 3.2. I get 7.6 sine of C over 3.2 sine of 99.2. Divide by 7.6. 3.2 sine 99.2 divided by 7.6. And then last step, C is the inverse sine of 41.56. C equals 24.6, but we haven't found S yet. We got one more to find. And the label C is 24.6. And you can show me the math, or we can just do in the calculator. 180 minus 99.2 minus 24.6 equals 56.2. So we had to find all of those pieces in order to be fully done solving this triangle. We use log cosines that we learned today, we use log sines that we learned last week, and then we use the triangle idea that we've known for days. Any questions?
How do you know when you do an inverse?
When you do not have the angle, if you're looking for the angle, you have to do the inverse trig function. Good question. All right, we're gonna go to lunch. It is 11:49. 12, 10. We'll be back. No, it's around 12:20. We'll be back.
Where are you eating them?
It's 12:20. You can go get lunch. You can go to the bathroom. You can go to a break. You can
Think so?
do a lot of things. Those of you on Zoom, I'm gonna mute us in here. 12:20, I need you to come back on Zoom. But I'm gonna pause the recording for now and cut back when we come